Very first one, we're going to bring up Lior Bar Shalom, CEO and co-founder of Arbell Energy, who's doing big things on a nano scale.
Hi everyone, my name is Leo. I'm co-founder and CEO of Arbell Energy. Everyone understands that today the world needs much more energy. AI, infrastructure, data center, we need much more energy. But in the other side, one of the most powerful source of energy is here, it's our sun. Every hour the sun provides enough energy to power the entire world for a year. The challenge is not the source. The challenge is how effectively we can convert it for energy. Solar panel with us for many years, but most of them can convert only 20% from the sun energy to electricity. Almost 80% are lost. And this is the bottleneck that Arbell Energy is going to solve. At Arbell Energy, we create a new generation of solar cell based on quantum dot. Our solar cell will be lightweight, flexible, and even can be transparent. The most important thing about that we can do the most efficient solar cell. To understand how we can make it, they have two core advantages. First of all, with any traditional solar cell, usually one photon can create one electron. Most of the remaining energy lost is heat. In our case, one photon can create multi-electrons. More electrons, more efficiency. Another important thing that our structure allows us to get a very wide spectrum of the sunlight, including the infrared. So together with more electrons, we actually can get the most powerful solar cell that ever had. It could be even 3x more efficient compared to traditional solar cell. Also, the material that we use is cost-effective, easy to make. We can print it in a cost-effective way of production. So together with our partner TNO, one of the leading research institutes in the Netherlands, we already proved this technology at lab. We also proved upscale. And now together with them, we want to take it outside from the lab into the pilot implementation. We will start with a transparent retrofit booster that will sit on existing solar panel. The idea is simple. Traditional solar panel lost efficiency over time. With our retrofit, we will bring back the efficiency they lost. The infrastructure is already there, so companies have interest to collaborate with us, and that's how we can start it. So think about lightweight, flexible, and extremely efficient solar cell that can fit for mobility, for data center, space application, and even utility. This is the next generation of solar cell, and this is what Arbell Energy brings to the table. Thank you very much.
Don't leave the stage just yet. We have 2 minutes for questions. Our judges are out here in the front, and they're going to be going live on their voting. And Gidon, of course, the first question for you.
Hi. What size panel did you produce in the lab? How do you connect your second layer to the electricity system, to the inverter or whatever?
So first of all, we made, as I mentioned, we collaborate with TNO. One slide was missing here. That actually we proved the technology on small scale. One of the big question was about the large scale, and we print large scale by 10 by 10. Usually any solar cell is a matrix of 10 by 10. So we already proved 10 by 10, but actually we can make it longer and wider. So this is the first thing that we will do. Regarding how we can connect to exist solar panel, it's exactly the thing that we're doing right now. Next month, we selected to be in Free Electron to collaborate with a company that comes from utility, and this is exactly the thing that we're going to do together to start bring our solution and together with them to find what exactly they want to do with us in the pilot, because they want to get some number that sometimes can be different from what we are looking for, and that's exactly the program that we selected be.
We have a question over here.
Can you please describe the team and the financial model?
The team, of course, the CTO is Matan Arbell, easy to remember. We also have Shamel that joined to the team. Ronen Lago, part of our team, Chief of Strategy. It's important to understand, right now we do the development together with TNO. So some of the team is also part there. So we bring the technology, and regarding the idea of the let's say, go to market and how we actually can do that. We are focused on to develop the technology. We still have way to do to make the most efficient solar cell. We need to focus on that. That's why we're going to collaborate with all kind of research institute and also see all kind of company that to do production, OEM and etc.
So can you discuss a little bit the progress, where you are on TRL and current achievements and traction?
Yes.
Who is your potential first customer, if you have any?
First of all, regarding the TRL, as I mentioned, we proved this technology on small scale and large scale, TRL 6. Right now, we actually want to take it outside from the lab to start to get all the durability testing, etc., outside from the lab. This is exactly what we are. So that's TRL 6. Regarding, what was the second one?
Traction. Who are your customers? What's the first industry you're planning to?
So the traction is already we contact with several companies that utility that use kind of solution that can help us to, first of all, to understand all kind of questions that will be outside from the lab. Company that some of them I can tell that I'm on the stage, but we talk already with big company that do utility, that use all kind of technology. They told us that they want any increase of even in a few efficiency will be important for them. So they help us to bring it outside from the lab.
So, perfect.
Thank you very much.